everybody. We're here at the University of Michigan Dearborn, my school, inside the Science Learning and Research Center. Upstairs is the Geospatial Laboratory where we're going to show you guys some things about rivers and streams. Here we have labeled some of the geomorphic features of a river, including a cut bank and a point bar. The thalweg is the deepest point of a river. It usually corresponds with the area of highest velocity. Depending on its strength and velocity, a river is either depositing sediment or eroding sediment away. On the inside of a curve, where the velocity is slower, the water is depositing sediment, which results in a point bar.
A point bar is a depositional feature made of sand and gravel that accumulates on the inside bend of streams and rivers, as you can see right here. Point bars are formed as a stream sweeps and carries the sand, gravel, or small stones across the floor of the stream and up the shallow sloping floor of the point bar. Point bars are composed of sediment that is well sorted and typically reflects the overall capacity of the stream. They also have very gentle slopes and an elevation very close to water level.
Here, on the outside of a curve, the velocity is higher. The water erodes away the sediment, resulting in a cut bank.
A cut bank is an erosional feature of streams. Cut banks are found along meandering streams. They are located on the outside of a stream bend, known as a meander, opposite of the point bar. They are shaped much like a small cliff and are formed by the erosion of soil as a stream collides with the riverbank. Not only are cut banks steep and unstable, they are also the area of a stream where the water is flowing the fastest and deepest, making them rather dangerous. Material that is eroded from cut banks is generally deposited in downstream point bars. Cut banks are nearly vertical and often expose the roots of nearby plant life. Particularly during periods of high rainfall and higher water levels, trees and poorly placed buildings can fall into the stream due to slope movements.
The result of all these cut banks and point bars is a meandering river. A meandering river is one that curves as it flows downstream. Eventually, the erosion along cut banks makes the meanders more pronounced. As the meander becomes wider, the curves become closer together. The rivers want to follow the path of least resistance. The river creates a shortcut and straightens between its curves, cutting off the original meander. This results in an oxbow lake. Oxbow lakes are usually horseshoe-shaped, like the meanders they once were.
You can see the results of sorting if you take a walk along the banks of a river. You might see in a point bar that it's mostly made out of sand or small pebbles. If you go farther upstream, you might find an area that's full of larger rocks. The farther the larger rocks travel downstream, the more rounded they become. So if you find a rock that's more angular like this one, that you know you're probably close to the source where it came from. Where this rounded one is farther away from the source.
Here we have two sediment samples, sand and gravel. Which of these do you think will erode the easiest? Sand. Generally, the smaller and finer the sediment, the less velocity or stress required to erode it. There is one exception, however, clay. Clay is sticky and clings electrostatically to itself, making it more difficult to erode. Hi. The geomorphic processes that we wish to study take many years to occur naturally. To speed up the process, we have reduced our experiment to a smaller size. This is a stream table. It can replicate many different stream scenarios. It takes minutes rather than years to observe. The material for this table is plastic. They come in different sizes and colors. Yellow, white, black, and very small red. This will be important when we talk about sediment transportation.
Only a couple minutes after the water started moving did patterns of sediment sorting, or the separating out of particles by size, begin to emerge. The largest particles, yellow and white, were too large for the stream to keep carrying and dropped out for the river to flow around, while the finer blacks and reds collected in the meandering flow. As my classmate points out, two more meander-specific features have been developing on our table. The first is a floodplain, the low, wide, flat area carved out by a constantly shifting river. The river's path is ever-changing because new sediment deposition and erosion are constantly changing the riverbanks that defines its flow. The second feature is an oxbow lake in the making, as the upper meander is slowly being cut off by the particle deposition of the small channel that has formed between the two river bends. Soon the meander and the water in it will be completely isolated as previously described.